Welcome to Space Station Zeta, home of high-tech facilities, state-of-the-art equipment, low gravity, and the most stunning views in the solar system. You're the math expert on board, and it's your duty to help the crew with your math wizardry. So hop in that Space Station Zeta jumpsuit and get to work. The latest problem to pop up seems to be a bad case of space bacteria. It's growing pretty fast, and soon gross space bacteria will be all over the station, including important control panels, the kitchen, and your sleeping quarters. Yuck! You're 1,000 kilometers above the Earth, zooming around about 16 times a day, and nothing on the station will get rid of this stuff. Where's a space supply store when you need one? Dr. Zora, the station's chief scientist, says that the bacteria is out of control and she thinks it'll take 5 hours to find a way to stop the bacteria from spreading. The bacteria started out in just one room. After an hour, it was in 2 rooms. But after 2 hours, it was already in 4 rooms. There are over 50 rooms on the station, and the rest of the crew all want to know how many rooms will be covered with bacteria by the time Dr. Zora finds a way to stop it in 5 hours. Space bacteria. Wow, talk about pressure. So just how many rooms will be taken over? Not sure? To help solve this problem, you need to know a little bit about exponential notation. Have you ever heard of exponential notation? How about bases or powers? Don't worry if you haven't. After today, you won't have any trouble with space bacteria or exponential notation. Exponential notation is a shorthand way of writing a number multiplied by itself several times. The factor that you repeatedly multiply is called the base. The exponent, also called the power, the n, indicates the number of times the base is multiplied. The exponent is written as a superscript n just above and to the right of the base. You read it as a to the nth power. For example, you would write 7 times 7 times 7 as 7 to the 3rd power. Simple enough, right? There are a few special types of exponents that are worth mentioning. Any base raised to the 2nd power is known as being squared. For example, 8 to the 2nd power could also be read as 8 squared. Any base to the 3rd power is referred to as cubed. For example, 4 to the 3rd power can also be read as 4 cubed. Now that you know how to write an exponent as a base raised to a power, you should know how to solve exponentials. In order to solve something in exponential form, all you have to do is multiply it out like you used to. For example, 5 to the 3rd power is equal to 5 times 5 times 5. When you multiply it out, you will find that 125 is a solution. Using exponentials doesn't just work with integers. You can multiply fractions together in a similar way. Rather than writing out 1/4 times 1/4 times 1/4, you can write it as 1/4 cubed or 1/4 to the 3rd power. Do you know what 1/2 squared is equal to? Remember that 1/2 is the base and 2 is the power. Just write it out as 1/2 times 1/2 and multiply to find the answer. Did you get it? The correct answer is 1/4. For now, just remember how to write a number that is multiplied by itself repeatedly as a base raised to a power, and that you can solve exponential problems by multiplying them out. Also remember that fractions, as well as integers, can be bases. It's time to face the gross space bacteria. So how many rooms will be infested by the time Dr. Zora finds a way to stop it? Now you know that this question can be easily answered by using exponential notation. Since the number of rooms infested doubles every hour, the base is 2. Dr. Zora will have a way to stop it in 5 hours, so the exponent is 5. That means 2 to the 5th power rooms will be covered in bacteria in 5 hours, which is equal to 32. Now you just have to break the bad news to the rest of the crew and tell them that 32 rooms will be infested with gross space bacteria.